The law of conservation of momentum. Now, the law says that a number of bodies are in bizarre action. They are in total movement, and if two bodies are moving in the same direction with mass m1 and m2, this being body A and this being body B, and naturally if the velocity of this body is greater than velocity of this body, obviously this will come into contact with this body at some point of time, and there will be a collision between these two bodies, and during the collision this body will exert a force on this body, which is force A on B, and this body B will exert a force on this body, which is F force B on A. And soon after the collision is complete, the two bodies will move with final velocities VA and VB respectively. And we know that momentum is nothing but the product of mass and initial velocity of A, and so also of B, and this is the final momentum, which is after the collision, which is final velocity VA and mass A of the body A. And here, and also the B also gets the same product of mass and velocity. According to Newton's third law, we know that during the collision this body exerted force on this, and there is an equal and opposite reaction by body B, and since the direction is right, this is positive force, and left, as you know the sign convention, going up and right is positive, and going left and down is negative. The sign convention holds good for all kinds of vectors, and therefore this being force being a vector, here also the right force is positive and the force acting in the opposite direction would be negative. That is force of body B exerted on force on the body A. And we know that the force is nothing but rate of change of momentum of, this is force of body A exerted on B, therefore the rate of change of momentum of body A will be the difference of final velocity and initial velocity by t. With this value is nothing but acceleration, and this is mass. And similarly we have the rate of change of momentum of body B, which is nothing but, now applying distributive property, I can multiply this with this and this with this, similarly this with this and this. As you can see, negative into positive gives me negative value, and negative into negative gives positive, and these t and t get cancelled. And now if I choose to get the sum of the momenta before collision and after collision, I can simply take this value to this side of the is equals equation, and this part to this side, so that the final velocities of the two bodies will be on the LHS or RHS, and the initial velocities will be on the LHS. And naturally moving a negative to the RHS will become positive, and this will also be having the same treatment. And from this derivation we can observe that the total momenta after the collision is equal to the total momenta before the collision, and therefore this explains that the momentum is preserved and it does not change, and it remains constant before and after the interaction between any system of particles or bodies. And in physics, this is what is called the mathematical proof of the statement or the law of conservation of momentum.